Good morning. Welcome to this session on mobile web performance auditing. If you can see past the glare of lights on bald, you'll see that that's what I look like. You can find me on Google Plus as Paul Lewis and on Twitter as AeroTwist. Hey, Paul, would you mind doing a performance audit? This is what my colleagues would say. Or if they're feeling particularly urban that day, sup, Paul? The point here is that over time, people have asked me to figure out whether something is fast or not. And so I've built up, over time, a way of figuring that out. And that's what I wanted to share with you. So maybe you find yourself in this situation where people are asking you to do more performance work. And you're wondering how you should go about it. Welcome. This is what we're going to talk about. Good. So the first question is, why even bother? What's the point? Well, as you've probably gathered from all the sessions that we've been doing, smartphones are on the rise, which isn't to say there's going to be a rebellion. I just mean that more people are using them. And one study reckons that just over a third of American adults are using the smartphone as their primary means of internet access. As Paul Irish said in his session, that means that the first experience that somebody has of you and your brand is going to be on their phone. This trend isn't just America, it is actually further afield. This is the global internet traffic percentage for mobile is on the way up. It's just crossing the 30% mark. Sometime in the middle of next year, if the trend line is to be believed, we will cross 50%. That will make it the majority. The thing about these devices, more people are using them, but they're performance constrained. If you have a performance problem on your desktop, when it hits the mobile device, it's going to be really painful. And if you're asking yourself whether this is a big deal, let's just cover the stats very quickly, a couple that are interesting. A 200 millisecond delay to Google results caused a 0.3% loss in engagement. This is a study that we did a few years ago. But if you like your stats a little bit more on the positive side, this is what Etsy had to say. Lara Swanson from Etsy, she said, when we eliminated Jank, and we'll talk about that in a little bit, on Etsy's activity feed, we saw people favorite more often and favorite more things, which is a sort of meta indicator for conversions, really. So performance matters, or as I like to say, hashtag perfmatters, which you can track along with, or you can get the sticker. I've actually got stickers. Come and get a sticker. You can wear it like a badge, put it on your laptop, put it on somebody else's laptop as a passive-aggressive measure. Just, don't want to call it out, but yeah. But the thing about mobile as well is that because the browser is the only thing that people have on the screen at that time, they have these really high expectations. In the way they also interact with it, with their touch, you feel the latency in a way you don't necessarily feel with a mouse. So you sort of, not only are these devices performance constrained, but people actually have higher expectations. Yay! And you might ask yourself the question, well, isn't it the browser's job to make things go faster? And the answer is, yeah, absolutely. And from a Chrome point of view, we have, and we are doing, and we will continue to make things faster. This is something that we take very, very seriously. However, there is a whole suite of things that we as developers get to control, and we get to decide for our sites and our apps. And so this is where the audit comes in, because it's really talking about the things that we get to control and how we can make sure that we're working with the browser rather than against it. So what then does the performance audit look like? Well, for me, it falls into two parts. The page load, how quickly did we get something on the screen? And then once it's on the screen, how well did it run? Were the scrolling, the animations, interactions, were those all fast? So we'll step through it bit by bit. We'll start off with page load. And the first tool I would go to on the audit would be this, Page Speed Insights. All you do is you pop in your URL like so, hit Analyze. It's really complicated. And ta-da! You get a score out the other side. You get a score for desktop, you get a score for mobile, and it will give you some user experience hints as well, like tap targets, legibility of your text, and so forth. So if you've got problems that might not be obvious when you look at your device and you run it, then this will start to pick them out for you. People ask what kind of scores they should get. These are my own personal scores. 85 on mobile, 90 on desktop, and I don't want to see any UX issues. You could disagree with these. I would recommend that you go and have a look at what you're actually getting as your scores. I tend to say that if you're getting in this range, you haven't got any major issues there. But what kind of things are we looking for? Well, I'm going to go blast through what I consider to be the bread and butter, the things that I think we've talked about time and time again as developers over the years. First one is unoptimized images. Because unoptimized images are going to waste your mobile data, and as somebody who's roaming in the States right now, I'm very acutely aware of my carrier back home and the charges they could levy against me if I were to download something that was very large. But it also increases site load time. 63%, according to HTTP Archive. That's the percentage of bytes in the average web page that is over images. So it represents this huge surface area of optimization that we can go after as well. Easiest way I know, if you have this problem, is just drag them onto ImageOptim. If you're on a Mac, there are equivalents for Windows, I'm sure. And it will go through, it will crush the images down, spit them out, and you're way better. Unminifed resources, so things like your JavaScript and your CSS, they also waste data, and they will increase your site load time. We've talked about this, I think, as an industry for a long time. So it's on my list because this is what I look for, but all the same, I would say it's something that I would expect everybody does already. Anyway, the one I don't think that too many people think about is the number of requests. Oh, maybe they do, but let's talk about this a bit. Every request that you're going to make, JavaScript, CSS, images, they're going to slow down your site. So that should also be on the list. And now we go into what I consider to be the ones that are, I suppose, more mobile concerned. This one, too many redirects. Not something that I think people think about initially, but let me explain why. Every redirect that you make is going to slow down somebody on their phone. And 40% of people apparently will abandon your site if it takes longer than 3 seconds. So I've taken the liberty of putting a timer here. If we request the site and it's your site, we incur the cost of DNS and a connection and sending some data. And on 3G, we'll be talking potentially up to a second to get this done. If we respond by saying, actually, what you're looking for is on the m.dot site, we now have to do another DNS lookup, make another connection, and send more data. And we're into that, potentially into that 2 seconds. And then we say, actually, what you really wanted was on this path. We don't have DNS this time, but we do have a connection and data. And all of a sudden, we're starting to get perilously close to that 3 seconds, and all we've done was show a white screen. This is bad and something that we want to avoid. Shock upon shock. The solution is to actually respond to the request. And if that sounds like a sort of roundabout way of saying m.dot sites might be bad, yeah, you might think that this is an easier way to solve that problem. So, on my list of things, and the things that PageSpeed Insights will also give you back, is avoiding redirects. So far, so good. We have this kind of list of things, this checklist of things, but we don't really know what it's like to load the site from a real-world location on a particular device and so forth. That is where Web Page Test is going to come in and help us, and it is not very complicated to set up. Here we go. Pop the URL in the top, and we ask it for a particular location and browser, and we say, in this case, I want 3G, number of tests, and because I'm feeling exciting, let's capture a video as well. That's one of the amazing features. I love capturing videos. We're going to look at that one in a sec. So we run this, and we get some results back. And at first glance, I always think this is a bit overwhelming. So let's dive into what we're seeing. Performance grades in the top corner. These are like the headline items of what you should be looking for. If you get reds in here, that's something that you want to look for and you want to fix. So if you click on it, it will tell you why you got the grade you got and what you need to go away and fix. The next thing we get are the performance details. How long did it take our server to start sending data back? How long did it take for the page to render? Everything that you sort of need from a numbers point of view. We also get a waterfall and a few charts. And then because I checked that capture video button, I also get this in the corner, which says watch video. So I thought I'd share the video of I made this test site, by the way. It is hideous, but I did it to show. It's not that I did this on purpose. Well, I did do this on purpose. Anyway, have a look. Well, I hope that was as agonizing for you as it was for me, frankly. 18.2 seconds to load something on a 3G connection. I've pulled out the 3 milestones that I think are dead important here. First of all, 6.5 seconds. That's the point at which we started to get something on screen. Up to that point, all we had was a white screen. And as we discovered earlier, up to 3 seconds for everything, and people start leaving. So that's bad. 9.7 seconds is when we actually had the initial viewport filled in, and that's something we'll come back to in a second. And then lastly, when everything's loaded at 18.2 seconds, we can consider ourselves complete. So this one here, saying that something is visually complete, is actually a really interesting measure because it represents something to do with perceived performance and how people feel how long it takes to load your site. And when we go back into those results that we had from web page test, the one number that should stand out for us then is this, which is that 9.7 seconds expressed as milliseconds, pretty much. There is a bit of a difference. The speed index is a really good measure for perceived performance. It's actually a link. You can click on it. It will tell you how it figures out what the speed index should be, and it is a bit convoluted, but it does represent the best measurement that we have for perceived load, not just the body on-load kind of event, which, as we saw, was several seconds later. I tend to, when I'm doing my audits, I tend to look for a speed index of around about 1,000, which is a very tricky number, difficult number to get, but it's actually a really valuable one. That's going to make your site feel really snappy to anybody who loads it, particularly on a mobile connection. Also worth pointing out is because I checked that capture video button, I have this film strip view, and if we look at that, it's pretty much like that video I showed, I suppose, in many ways. But you have the white screen there at 6 seconds, you have visually complete at about 10, and it's basically up to this point, up to this sort of 10 seconds, is what we call the critical rendering path. This is the point where we have to sort of figure out, well, what does the browser need in order to get things on screen? And that comes in 2 parts. It's what information does it need, and then how can we stop it being blocked in doing that? So for example, JavaScript can block rendering, as an example. The thing you want to do is to prioritize the critical rendering path. You want to make it easy for the browser to get something on screen. That will lower your speed index, and it will make your site feel a lot snappier. Prioritizing the critical rendering path is a big topic, too big for this, so I will point you towards the Google Web Fundamentals, which we recently launched. I've created a short link there if you care for taking that down, bit.ly/iocrp. There we go. That is a whole documentation on how you can prioritize the critical rendering path. Looking at the waterfall that we get, first thing is those redirects. PageSpeed Insights will have told us that we had redirects. This is going to confirm that, and each one of those, you can see, slows us down. The other thing I thought was quite interesting in my fake example is that I'd duplicated files. I'd requested jQuery twice, but I know that this is perfectly reasonable and possible, having seen it in the wild, that you have multiple developers. One pulls in jQuery, the other one pulls in jQuery, and whoops, didn't realize we were getting it twice. If you look at your waterfalls, you might start to see those kinds of patterns. The other thing I noticed is that we've spent a long time transferring one of the images, that dark blue. Most of the time, it's not actually spent transferring bytes. It's actually all the different connections and so forth, which comes back to the number of actual requests. But in this case, we do have a long transfer time. So far, so good. This is the page load. So it's optimizing resources, reducing the number of requests, it's avoiding redirects, and it's prioritizing the critical rendering path. And I think most people, when they hear that, they go, fine, but that sounds like a lot of work. Yes, it can be, but there's good news. Grunt and Gulp both have tasks galore to help you do this. And so all you need to do is just run them with these tasks, and it will hopefully help you. In fact, when I ran through this talk, my colleagues went, I need the closure. They don't sound like that. That's me doing a mean impression of them. And so I said, OK, fine. This is me running grunt. 8 whole seconds later. Ta-da. And now, my page speed insight score is 100. But really, when somebody loads it, you'll notice that the speed index has dipped to 1,396. Just following page speed insights' guidance, following web page tests guidance, will help you significantly. In this case, we're 6.8 times faster. Yay for me, but... Wait, no, I made it 7 times slower on purpose. No, it's all good. So that's page load. For me, it's those kinds of things. The bit where I normally kick in is this bit, the runtime, because for me, I get very frustrated even when something loads quickly if it is horrible to actually use. And other people notice that as well. Let's come back to what Laura said. When we eliminated Jank, better, better, more, more, brilliant. OK? Jank. Jank is missed frames. But then you go, hang on a minute. What's a frame? Exactly what are we talking about here? Yeah, let's set this one out. Your modern smartphone refreshes its screen about 60 times a second. For us, then, we actually have to get 60 pictures or 60 frames onto the screen. And that means that for that 1 second, we will have 16 milliseconds in which to create those pictures. And so it becomes very important to understand how those pictures are made and how we control that part of the process, because we really, really do. So let's talk about how Chrome goes about making a frame. This is the Chrome one. To be honest, most browsers actually go through a very, very similar process. But this is the Chrome-specific bit. The first part of the process from a developer's point of view is the recalculation of style. Here we've got a DOM tree. I've simplified it a little bit. There's nothing under head. There normally would be. But you get the idea. We have a DOM tree. We've parsed our HTML. We've created this tree. And what we do is we bring in the CSS that we have from the style sheets that we have from the user agent. And what we start doing is we start saying, OK, this applies to these elements, and some of it will cascade down. This from the user agent actually switches off the head because we don't display that. Same goes for scripts, and so on and so on and so on. The browser does it faster than I would. Till we arrive at this. This is a new tree called the render tree, and it's all the things that we care about putting on screen. So we have this tree, and we know all the things about, all the, in theory, what the colors and the positions and how everything relates to everything else. Now we actually have to figure out the geometry of the page, and we call this layout. So we push this in, and I marked it out with boxes. This is where we think all the elements are going to be. And the thing about this part of the process is the unique-ish layout model of the web means that one thing can affect another thing. If I change the height or the width of the body, then the things that are inside the body are probably going to be affected. So it starts to matter about how we start to deal with our elements as to whether layout will be a problem. Next, we actually have to start filling in some pixels. So let's start with our boxes. Let's fill it in white, pop in a header, a couple of UI elements there, some buttons, bit of text, bit more text, hamburger icon. Argue with whether that's a good thing. User experience people aren't so sure. Title, date, and we're good. We've filled in our picture. We've had this one bitmap in memory that we've drawn our pixels into. Super. The final part of the process that we care about is compositing. Now, to understand compositing, we actually have to go back to Paint a second, where let's say we've got a different header that we want to put in. Let's say we're fading between that darker one to that brighter one. Well, this area in red is considered dirty. And so we paint in our new header, but now we actually have to repaint the hamburger icon, the title, and the date. And you start to sort of say, hang on a minute, that's not great, because we've had to paint a bunch of things that didn't even change. Well, the good news is we can, and we do better. What we actually do is we create these things called compositor layers. So these things are in sort of separate space in this picture, but really you can see the header is animating all by itself, and we have this separate layer that we've painted all the other content into. And the idea is now we can keep them separate, and when we're repainting, we don't have to repaint the things that didn't change. So that's compositing. The good news is that Chrome DevTools will show you frame data. If you load up DevTools and go to the timeline tab, you can see something like this. This is zoomed in. The things that we care about is there's this line here at the top that marks the 30 frames a second. 30 frames a second. This one is 60 frames a second. And you see here, when you're running your page and this is recording, you'll start to see these bars appear. This is your page's frames per second. And when we zone in on one of these bars, we start to see these records appear at the bottom. And they correspond to that pipeline that we just discussed. Recalculating style. What applied to what CSS applied to which elements. Layout, figuring out the geometry of the page. Paint, filling in the pixels, and of course, compositing, putting all those layers back together. So now that we know about how Chrome and other browsers create frames, I would like to introduce you to my friends, the 4 horsemen of the JANKOCALYPSE. These issues are my greatest hits, as it were, of Jank. That's not to say they will occur in every project, but they're the things that I'm looking for when I do the audits. And they're as follows. Firstly, expensive animations, and you should consider scrolling to be an animation something is moving on screen. Let's take a pretty innocent-looking example, I suppose. Let's assume we're making a card-based system, because that's pretty popular on mobile. And we have this expanded class. We tap, say, one of these cards, and we expand it out to 400 pixels in height. And we're going to just do a CSS animation, because we've heard that that's good, or a CSS transition. That's also good. It turns out that this isn't quite as good as we'd hoped. And to understand why, what we're going to do is, notionally, we're going to plug in our Nexus 5 into our machine over USB. We'll go to Chrome Inspect, and you'll start to see that the tabs appear that we have open. I have an animation on Layout tab open here, and all we need to do is tap Inspect, or click Inspect, and we'll start bringing up DevTools. So we have our card example here, we have DevTools, and the little red light says that we're recording. And when I tap on one of these cards to expand it, boop, you'll see that we've shot out the top of that, even the 30 frames a second line. And when we click on it, we find out that we spent 23 milliseconds figuring out the geometry of the page, because as we expanded one of those elements, we had to move all the other ones down, and we had to figure out what happened to the geometry. And that was expensive on a mobile device. And you also notice that we spent nearly 600 milliseconds painting the pixels. So when we're supposed to be doing 16 milliseconds in a frame, to spend 600 is going to kill our frames per second. So this, for your users, will appear as janky. Of course, this is one situation. It's not always the case, but generally speaking, I tend to find that layout will trigger these kinds of performance problems. But you can see how you start to figure it out yourself with Chrome DevTools. So from a kind of frames point of view, if we go to these 16 millisecond markers, that layout, even just the layout pushed us past that marker, and now the paint just killed everything for us. And it's not much better if you go straight to paint. I have a bit of code here that's going to send something to hot pink. Why wouldn't you? And again, we're going to use a CSS transition. Similar kind of situation. Let's have a look at what we see when we run it in DevTools. Tap it. Boop. And you can see, again, we're not even hitting 60 frames a second. In fact, there we are, 72 milliseconds just painting each of those. Again, you might find that that's not always going to be the problem for you. But even so, it's probably worth figuring out the tools. Do excuse me. There we go. Failure to plug in. There we are. Please tell me that I didn't kill something. I'm back. Thank you so much. OK, good. Whew. Move along. All right, so you might be asking yourselves, how can we get high-performance animations on a mobile device? Great question. And the answer is to stick to these, actually, is to stick to transforms and opacity changes So the transforms obviously translate, scale, rotate. There we are. And opacity there. Now, the only note there is that the element will need to be on its own compositor layer, just like the header that we had before, which was on its own layer. And you might be saying, well, OK, fine. How does something get its own layer? Great. OK. Well, there's a new property that is in Firefox, and it's in Chrome. It's currently in Canary, I believe, is will change. And will change, you can tell it about the things that are going to change from a visual point of view, like transform in this case. Or you can tell it about something like opacity. You could use left, top, depending on what it's going to change. And you're now trusting the browser to create compositor layers or just make the right optimization for you. And that's a really good thing. One kind of note of caution here is that if you create too many compositor layers, you could find that your time in compositing goes through the roof. So that's something to watch for in terms of those records that you see in DevTools. So let's go back and see what happens when we just animate transform and opacity. Here we go again. There we go. A very smooth 60 frames a second is what you'd experience. And you'll notice that we spend a fraction of a millisecond recalculating each of the frames of our animation, and then a fraction of a millisecond compositing things together. People often say, well, how come I'm seeing transparent bars up here in DevTools? And the answer is, essentially, those frames are empty. The workload was so light to do compositor-based operations compared to doing layout and paint that we can now fit it comfortably inside the 60 frames a second budget. So from a kind of frame point of view, we recalculated style, we did compositing, all was well. So in terms of this kind of waterfall, we would like to be down here. Is the long and the short of it, rather than starting right up, say, at the top with layout and then paint. So then, having explained all that, the first item on my list is, am I seeing expensive animations? If so, I will start to suggest that people restrict their animations to these properties. The next thing I see quite often is mistimed animations. It's still true, I believe, today that jQuery uses setInterval for its animations. And the problem that you have when you use setInterval for your animations is that you'll find that your JavaScript, your setInterval fires at some point inside your frame. And sometimes you'll miss your frame, and sometimes you'll hit your frame. But for your users, what they'll see is they'll see it judder and jank. What you should be doing instead is using requestAnimationFrame, because it gives you this. It gives you a consistency and the scheduling, the knowledge that you are going at the start of the frame and much more likely to hit your happy point. So the second thing I look for is sane use of requestAnimationFrame. Layout thrashing continues to be an interesting one. And what this is, let's take a fairly contrived but fun example. We'd like to resize all these paragraphs to be the same width as this blue block here, like so. And the code for this, I think, would be pretty trivial. We'd loop through our paragraphs, we ask for the width of the blue block, and then we set the first paragraph. And we go round the loop, and we ask for the width of the blue block, and we set the second one. And if you run DevTools against this, you'll start to see something that looks like this. The first thing to notice is that we have a monster frame, which is about 2.65 seconds. When we look into the records of why it was a monster frame, you start to see that we've gone into this bizarre cycle of reading and writing styles. And what's actually happening is we're asking for the width of the blue block, and then we're doing something to invalidate that calculation by setting the paragraph's width. DevTools actually puts this yellow triangle, and this is a warning to you, which it's going to call it a forced synchronized layout operation, which is its way of saying, you made me go away and do some layout calculations, figure out the geometry of something, its width, its height, its padding, its margin, when I wasn't expecting to. And we're going into this kind of thrashing between the two states. Instead, what we should do is ask for the layout property once at the start, and then do all the writing. So it's this kind of more general rule. When I see a layout thrashing, I would say, read any layout values, then write them. That said, if you're going for the first one, you'll probably try and avoid layout during an animation. The last thing that I look for, the fourth horseman of the JANKOCALYPSE, is garbage collection. Garbage collection has the ability to essentially interrupt at any point. It's an undeterminate point in your frame's lifecycle. When we switch over to the memory in DevTools, the memory profiler, you see here we have one of these drops. So we see this chart of memory going up and down, up and down. Every time it goes down, that's garbage being collected. In this particular situation, I have a large amount, about 40 megabytes of garbage, so stuff that has been released, and it takes Chrome 10 milliseconds. Now, this has actually got a lot faster over the last few years, but it can still knock you off in terms of your frames per second. Oh, it hurt. And this is why. Basically, it's something you don't have control over in that sense of when this is going to happen, but if it does happen to you, then you will not make your 60 frames a second. So, writing fast memory-efficient JavaScript is a big topic in and of itself, and so I will just point you to this, which is Adi Osmani's article by that very same name. I like the fact that Adi's not even looking at anybody here. He's just aloof. Doesn't want to look at us. All right? Good. Runtime, then. For me, it's restricting animations to transforms and its opacity. As I say, these aren't always going to crop up, but this is what I'm looking for. It's the sane use of requestAnimationFrame. It's reading layout values and then writing them if necessary. And it's writing fast, memory-efficient JavaScript. As I said, these aren't always going to crop up, but when they do, these are the things that are going to stop it feeling silky smooth on a mobile device. So far, though, this is what I spend my time looking at. So like I said at the start, the future that we face is with these things. It's with smartphones. And they are performance constrained. When you hit a performance issue, you really know about it. And people have higher expectations of performance on mobile. Bizarrely, they do. And so we really need to meet that expectation. We really need to make fast-performing sites and apps. And the way you're going to get there is to start by gathering data. The tools that I've shown, Page Speed Insights, Chrome DevTools, Web Page Test, they should be the bread and butter. You should go away and run those and see if you can figure out what's happening. But the tools themselves will let you gain insight. They will actually tell you what the numbers mean, why you got the scores you got, and what you should do. This is Page Speed Insights saying, here are all the reasons why I think you have illegible text. And if I fix all these, then I'm good. Which is to say, the final part of the puzzle is to take action. It's no use getting all this information, all this data, and then doing nothing with it. So if I can ask you to do one thing, it would be to go forth and audit. Thank you very much. All right, you can let me know what you think with the session feedback, and I will be outside for Q&A after this.